we're going to be doing our demo for today. There'll be two different demos. So the idea is that we're going to simulate the whole concept of thermochemistry in a bag. So maybe some of you are familiar with one of those hot packs or cold packs. For example, if you have worked out or you're injured, you might have to use some cold packs to help with your muscles. Or if you're going skiing and you need something to warm your hands, then you can get those warm packs that you could break, right? Certain chemical reactions happen to there. Our focus for today's demo will look into one that will have an exothermic reaction and one's going to produce an endothermic reaction. A lot of the discussion we'll do together. So I'm just going to go through the whole procedure and I'll point out some things since you're not here to observe. All right, first one we're going to try out is calcium chloride. And for this one, I'm going to measure roughly. And I pre-labeled our weigh boats here to make sure that we don't contaminate. So let me zero this. Try it again, 0. Oh wait, try this again, 0. It's not responding. For some reason, there it is. Okay, so we're gonna roughly measure 20 grams is the estimated amount of our calcium chloride. But we don't necessarily have to get to, because I don't want to waste our, in fact, I'm gonna lower the suggested volume to 1/4 of that. So I'll just adjust everything. Since this is more of just a demonstration anyway, it's pretty close to our target. Essentially, everything's now reduced by 1/4. So I'm going to add that to our small beaker here. Let me remove our stirring rod for a second. Try to get all of your calcium chloride in your beaker. And so since I have to do the adjustment, now it'll be about 10 milliliters of water. So I'm just going to use my other beaker. I wish I have a graduated cylinder. In order for us to measure roughly 10. Again, this is a bit of an estimation. The idea again is we just want to make sure that we could produce this chemical reaction. So the current temperature, let me move this so we can see our temperature here, is about 21.8 degrees. So it's kind of the room temperature in this room right now. And I'm just going to add and allow for this reaction to happen. Keep swirling this, keep swirling. As you can see, the temperature is increasing pretty readily. And if I hold on to the outside of the beaker, it feels really warm. So it's something that we're going to have to discuss with regards to, it's pretty soluble. Keep in mind that chlorides are, on their list of solubility, one of the more soluble compounds. At this stage, it's pretty much dissolved. Our temperature looks like it's kind of holding steady now. It looks like the maximum temperature we've gotten is about 35 degrees Celsius. All right, so that is our first demo. Again, the discussion of the science behind that we'll have to do in a little bit. So that was calcium chloride in water. So let me just do a quick rinse, and then we're going to set up our second demo. All right, for a second demo, so that was our heat pack. Now we're going to do a cold pack. For this one, I need to make sure that we have a dry container. Give me 1 second. So I'm going to dry one of our smaller beakers here. Make sure there's absolutely no water. In addition, I want to make sure, since I rinsed our thermometer, I kind of need to get rid of any of the remnants of our chemical from the first demo. All right, so here's our beaker that was rinsed, it's clean. And now I'm going to add about equal amounts of our two reagents for the second demo. This is ammonium thiocyanate, NH4SCN, and barium hydroxide. There's something extra added to this barium hydroxide, but it's kind of something that we'll discuss once we finish the demonstration. But those are our two reagents, both of which are kind of a crystal or powdery in terms of how they look like. So I'm just going to measure starting with ammonium thiocyanate, zero this again. Just want to make sure I have equal amount for each one of them. Make sure I have the correct one. It would be this. So let's go with just enough for us to see the visual of this. For a better scopula. I'm gonna keep going. So maybe let's try to get to like 5 grams, comparable to what we had earlier. Almost there. And maybe one more scoop here. Okay, so again, this is just a demo, so we're trying to get close to value. So this is our ammonium thiocyanate. I'm going to set that aside for now. Make sure it's closed. So as you can tell, it's dry and it's a kind of powdery crystal look to it. And we have our barium hydroxide. I'm going to do the same. So let's zero that. Again, make sure that I don't contaminate. So I'm using a different scopula for it. I'm going to try to match that exact amount. Or at least close to it. Added too much. Still too much. Try to get as close to the number we had from. Okay. Seal this. All right, with that, we have our two reagents. And the task is pretty simple. We're just going to add both of them into our beaker. Let me see if I can get a better contrast for us. Something that will. I'm going to put this paper underneath. Or actually, something about this demonstration, it requires a little bit of extra help from a piece of wood. And I'm going to add some water. So there's a little bit of kind of puddle of water right there. And then I'm going to add our barium hydroxide. So our barium hydroxide is there. So you can see it's just the powder we pre-measured earlier. And then the ammonium thiocyanate is going to be added. I'm going to put this on top of that block of wood. Keep measuring that. In fact, what I'm going to do is put our thermometer in there as I'm going through the stirring. As you notice, there's already certain kind of changes occurring to our, it's looking a little sticky. And as you can look at the temperature, we're now at 1 degree. Now we're at -1, -2. So many things are happening. This is getting very cold. It's now at -7. The two powders had changed into something that's more liquid. So we're about -8 degrees Celsius. Okay. I think this would be a good stopping point. I can smell a very strong scent. It smells like ammonia. And our temperature again dipped down to about -8. I'm going to remove our thermometer, transfer this over here, and let's see what happens. So we're able to lift up that block of wood. In fact, it's very hard to remove. So something that we're going to be talking about. So our starting compounds were all earlier. They were all both solid crystals, and now we're dealing with something that's liquefied. So that's the end of our 2 demos, and we're going to talk about the explanation in class.